Welcome and hello. This is a video exercise on HEC HMS. And in this exercise, we are going to be working with the importer tool and the normalizer tool. All right, what I have on the screen here is a blank HMS project. What I'm going to do is create a project from scratch, load in a subbasin, and then we're going to go online to gather some sources for precipitation data, and then use that importer tool and normalizer tool. So File, New Project, give your project a name, and then click on the folder icon here to navigate to where you want to save that project. All right, so click Select. I'm going to use US customary units and then Create. All right, first thing I want to do is create a basin model. So click New. I'll just call it Basin 1. Close the manager, and then boom, here is my basin model map. Now what I'm going to do is import a shapefile to represent the sub-basin. And this could be any shapefile or any polygon subbasin that you want. I'm going to go to a different project real quick and just grab a shapefile here to copy. But yeah, again, the exact location is sort of up to you. So copy that. Okay, here's my project. I'm going to put that into my project's GIS directory. And then now I'll go back to HMS, click on GIS, import georeferenced elements, select subbasin, next, and then I'm going to navigate to that GIS directory right here, and then click on the shapefile and select. Next, name is correct. We're good here. I think the coordinate system is already in place. Yes. All right, so here is my shapefile. This happens to be in Northern California, but that's really not too important. This webpage in the HEC HMS tutorials and guides talks about downloading the MRMS precipitation data. I'll leave a link to this page in the description. But what we're going to do is download one of the Python retrieval scripts, which is a little bit further down here. And then we will modify that slightly, download the data we want, and then bring it into our HMS. Go ahead and click on this link, data-retrieval-scripts.zip, and then that'll download to your default download location. And then what I have here on my desktop, I'll go ahead and open that up. The script that I want to use is this retrieve QPE gauge correct 01h.py. So I'm just going to drag that onto my desktop, close the zip file. I can delete that zip file now. Now I'm going to move this script file into my project just so it's not on my desktop. And within my project, I'm going to go ahead and just create a new directory. I'll call this scripts. Okay, so I'll move that right there. All right, let's go ahead and open up this file and see what we have. What it is a script to download some precipitation data from this Iowa State University webpage. The only lines that we need to modify in this file are going to be the start and end time as well as the destination. We're going to look at the month of April 2018. So I'm going to change these numbers to be April, and it's going to be for the entire month. So that looks good for the start and end date time. And then for the destination right here, what I want to do is just create a folder on my desktop to keep it easy. And then I will move it to the project directory once the files are downloaded. So file, I'll go right click, new, folder. I'm just going to call this Precip MRMS. And then from that, I'm going to right click and then copy as path. So then right down here on line 15, I'll paste that path in. And I can either change my slashes or just put an R character right there, and it should work. Okay, that looks good. And save. All right, to get that download started, let's go ahead and create a command. I'm going to just open up a new text file. The first command is going to be the reference to the Python interpreter, the executable. And then the second argument in the command is going to be the path to this script right here. Let's go ahead and find that first argument, which is the path to the Python interpreter. My C drive is going to be in users, my username, app data, and then local, and then it should be in programs, Python. There it is. 3.13 is the version of Python I'm using. And I can just right click on that .exe file, copy as path, and then let's go ahead and paste that into our blank text file. So this is the first argument. The second argument, like I mentioned, is the file path to this script. And I'm just going to be running this locally here on my computer. So let's go ahead and find that. It is going to be right here in my scripts directory. right click, copy as path. Okay, let's go back to that command that we're working on. Here it is. I'll give a space and then paste. Okay, that looks good. So here's the first argument. That's the path to the Python. And then here, the second argument right here is the path to the Python script, which should be downloading the files right here. So I'm going to copy that, Control C, and then click on the Start menu and just click type Command or CMD for command prompt. There it is. And then let's go ahead and get that started and then work on the other things. So I'm going to go right click and that pasted and then enter should start the process. So let's go ahead and check on our directory. All right. So what I'm seeing right here is that the files are starting to load in place. It's downloaded 12, 13, 14, 15 items. This is hourly precipitation data for 1 month. So on a 30-day month, that's going to be 720 records. And right now we're only at 24 the first day. So let's go ahead and let that run and then check back in later. While that's running, what we can do is download the PRISM data. The PRISM data is going to be assumed to have the correct volume, whereas the MRMS data is going to be assumed to have the correct temporal distribution. On the screen now is the PRISM website for downloading all sorts of data. I'll leave a link to this page in the description as well. What we want to do is first go to recent years, and then we're going to select precipitation in the radio button. That's already selected for me. And then below that, we want daily data. So click the radio button for daily. And then we want to choose the year 2018. And then the month is going to be April. Now I want every day of the month. So don't choose a day, but just go ahead and click on this link here. Download all data for the month. All right, so that's downloading and that's done. So let's go ahead and see what that data looks like. All right, this is bill data, I believe. Yep. So these are bill files. I'm going to move this into my HMS project directory. So let's go up to data. That's a good place for it. Nothing here yet. So I'm going to go right click, new. I'll just call this Prism. Okay, I'll open up that directory. I'll come back to the Prism data I just downloaded, select all, and then drag it over. Okay, so that's copying over. All right, that's copied. So I'll just delete the zip file of bill files of Prism data on my desktop. I'm going to check back in with our downloads. We're up to 211, 212. So that's working away. That's the MRMS data. While that's working, let's go ahead and use the importer tool for our Prism data while we're waiting for the MRMS data to come back in. So let's go to HMS, and then I'm going to go File, Import, Gridded Data, Importer. All right, here we go. It's asking us to add the source file, so I'll click on the folder icon over here. Here is my project, so I'll click on that, and then the data directory, click on that. Now here is the Prism Precip data. Here are my files. I'll select them all by Control A, click Open, and then click Next. All right, we need to select our variable. So the PPT is the Prism code for precipitation. That's correct. That's what I want to move over here to my right list box, and then click Next. All right, for this screen, what I want to do is specify the clipping source. This is going to be the shapefile of the subbasin. Whatever shapefile that you imported into your HMS, go ahead and navigate there. Here is my project. I'm going to move over to the GIS directory now. Watershed.shp is just what I called that polygon shapefile that is georeferenced. For the coordinate system here, I'm going to use SHG, okay. And then for the cell size, I'm going to use a relatively small cell size of just 50 meters. This is my watershed happens to be rather small, so that's a good fit. And then I'll click Next. Now I need to specify an output directory, a DSS file for the different paths to be written to. Once again, I'm navigating to my project, which is right here. I'm going to put it in the data directory. And now I'm going to call this prism.dss. So here are the raw files in this folder. This is a DSS file with the imported data. And then for part F, I'm just going to say prism and then click next and then wait for that. All right, cool. I'll close that for now. The data has been written. Let's go ahead and see what that looks like. I'm going to open up DSS view and then open up that file. Here is my project. And then let's open that up. Data directory, preset prism. All right, here are my records. So we have 30 records, one for each day of the month. And then let's just go ahead and look at the data itself. So here we have some data. This is 85, I believe that's millimeters. Yeah, millimeters, and that's the daily total. So I'm going to just cycle through some more of these. Okay. Okay, I'm checking back in with the MRMS data download. We just crossed 500. So out of 720, we're well over halfway there, about 2/3 of the way there. While we're waiting for that, let's go ahead and look at the cumulative precipitation for this PRISM data. And to do that, I'm going to throw in a bonus tool here. That's the grid to point tool. So go in HMS, select tools, data, grid to point. Now what we're going to do is select the DSS file for the PRISM precipitation data. Here is the project, and then here's the data directory. Here is the prism.dss. I'll click OK or open that up. Select all the records, all the paths, click Next. Now for zones shapefile, this is the same shapefile of the subbasin we want to specify. Okay, here is my project, and then here is the GIS directory and the shapefile, and open. The field is name, that's good. And now what I want to do is specify a DSS file. I'm going to create just a new DSS file, not try to add the time series dataset that this will create into an existing DSS file. So here's the project. I'm going to put that in the data directory, and then I'll call this precip time series prism.dss. All right, open, and I'll again call this prism as the source, and next, and close. All right, let's go ahead and see what that looks like. It should be a time series data set, which is the average value of the precipitation over this entire subbasin for the month of April 2018. All right, here's that record. It should just be a single record. Okay, I think it's got a record from the previous month, which would be March. Let's see here. Let me see what it looks like. Oh, no, I'm sorry. So one is incremental and one is cumulative. That's cool. I'm really just interested in the cumulative one, though. So there's that, and I'll click on it. All right, looks good. So it looks like we have over 7 inches of precipitation for that month. Let's go ahead and look at the table data. If I scroll down to the bottom, indeed, we have 7.297 inches of precipitation. So let's go ahead and check out that MRMS data download now. Where are we at? 693. And it looks like it's holding there at 693. If I look at the command prompt, it has returned the prompt to me, which means the routine is done. So I'll close that. Let's go ahead and move this MRMS data now into our data directory. All right, so here is the project, and then data. I'm going to create a new folder here. New folder, precip MRMS. And then this is actually zipped data. Yeah, that's fine. We'll just unzip it in place. I noticed it was zip data because of this .gz suffix at the end of the file name here. So that's not a problem. I'll just select all the records, right click, show more options, and then 7-zip extract here. And then let's wait for that extract to complete. All right, that looks done. We have now doubled the number of files in this folder, which means we want to delete all of these .gz files because these are the zipped up files that won't actually import. So I'm going to just scroll down to highlight all those zip files. And what we want is just the grib file, which is a single file within each zip file. And delete. Alrighty, that looks good. All right, I'm going to drag that into my Precip MRMS data. All right, great. So we don't need that anymore. Now let's use the importer tool on this Precip MRMS data. That's going to bring it into the DSS file format that we can use for HEC programs, but HMS in particular. Import, gridded data, importer. All right, let's navigate to those MRMS files now. Precip MRMS. All right, let's select all the records. There's some 693 records, I believe. So we have a few missing hours, but over the course of a month, that's not too bad. Okay, I click next. It's just taking a while because there's more data here. This first variable is the one we want to select. That's for the precipitation. So move that over, click next. Let's navigate to that shapefile. Okay, it's right there, easy. I've already used this tool once, so it opens up in the same directory that I opened it up in last. We're going to use that SHG projection and the same 50-meter cell size, and then click next. All right, next we need to specify the output. So I'm just going to sort of keep with the same format here with the PRISM data. I'll call it Precip MR mrms.dss, and then open. And then for part F, I'm going to call this MRMS, and then click next. All right, so this is going to take a moment to do all the processing. All right, that got finished up. Good. I'll close that. Let's go ahead and look at the data. So I'm going to open up ESS view again, and then Control O to open. We're looking for precip mrms.dss. I'll open that up. Now, yeah, we have 683 records. So I'll select them all and then go ahead and click the graph button. Looks good here. I believe we don't have any precipitation for the first few days here. And on an hourly time step, that means I just got to click through about, so we're probably in the April 5th. There we go. So we have some hourly data. So this is hourly instead of the PRISM data, which is just daily. So we have a more accurate distribution of the precipitation in this area for this month of April 2018. Let's go ahead and run that grid to point tool once again, but this time on the MRMS data. So back to HMS, that's tools, data, grid to point. We will be getting to the normalizer tool just after this. So grid to point, I'm going to select the MRMS data now. So here is the precip underscore MRMS, open. I'm going to select all the records, move it over. Next, we want to use the same shapefile to clip. It's in the GIS directory. Watershed.shp is what I'm calling mine. The field will be name. That's good. And then the destination will be, I'll just put it in the same data directory, and then I'll call it precip tsmrms. So that'll be tsmrms.dss. Okay, so for part F, I'll just call it mrms, which is the source, and next. All right, grid to point is complete. We can close that. All right. I'm going to go ahead and open up that file. Here is the data set. So we have cumulative and incremental. Let's just look at cumulative again. And what we have is a total of about 4 inches of precipitation. That's using the hourly MRMS precipitation data for April 2018. Now, if you remember from earlier, we had like 7 inches or 7.2 inches using the PRISM data, and that's what we're going to rely on. So this process of importing and then now normalizing, the normalizing tool is going to increase this hourly cumulative precipitation data so that it matches or closely matches the total monthly precipitation of the PRISM data, which will be our quote normalizer data set. Let me go ahead and just move these into the same DSS file so I can observe them together. I'm going to go up to File, New DSS file. I'm just going to call it Data, kind of as a catch-all. Okay. So what I'm going to do is I'm going to move these records over to data, or I'll copy them. So copy data.dss. Okay, that's been copied. Then I'm going to do the same thing with the PRISM time series data set. This is the grid to point results. Edit, copy. Again, move it to the new data.dss file. Now let's go ahead and refresh that data.dss file. Cool. Now let's select both the cumulative records and we can see how these two compare. All right, I changed the color so we can see them a little easier. And as you can tell that we have a large discrepancy in the total cumulative precipitation across that month. What we want is the distribution of this blue line to have a matching total or a near matching total with the red line here, which is the PRISM data. That's where the normalizer tool comes in. So let's go ahead and go back to HMS. There's a tool, data, normalizer. Now we want to first select the data set that's our source that we want to normalize. That's the hourly MRMS precipitation data. So let's navigate to that data set, precip mrms.dss, open. I want to select all the records, Control A, move them over, next. Now I want to select the normalized file, which is the PRISM daily precipitation data. So that is in this data set right here, precip underscore PRISM. I'm going to select all the records, move them over, and next. On this dialog box, now I need to specify the normalization period, the start and end date time, as well as the normalization interval. So we're going to go from April 1st through April 30th. Now the PRISM data starts and ends at noon, 12 o'clock. So that's what I'm setting for the time over here, 1200 hours. And then the interval I'm going to set to 1 day. which is, it is sort of up to the discretion of the modeler what they want to use. Sometimes a longer time period is better, but I'm just going to go with 1 day, and then I'll click next. Okay, the destination file, I'm going to go ahead and save this into, here is the project, here is the data directory. Now, just with the other two data sets, I'm going to type in precip mrms normalized.dss. And then for part F, I'm going to just call this mrms normalized. And next. All right, that's done. Okay. And then let's just confirm we have that record. I'm going to open that up. So it should be opening up. So right here in this file, these are the precipitation gridded data sets that I'll be using for my simulation. Once everything else is up and built, this exercise is just about generating this grid set here. So let's go ahead and just take a quick peek at it. And then after that, we'll use the grid to point tool so we can compare the final results here. We should get the storm showing up in just a little bit here. This is hours I'm clicking through. Okay, here is the storm data. We should have some data here. Okay, we have some data here, but it's also skewed by this corner of the ocean, which has extremely large numbers. So the scale doesn't look quite right, but the data is there. All right, lastly, let's go ahead and run that grid to point tool within HMS. So I'm going to go to Tools, Data, Grid to Point, and I'm going to select the source of that MRMS corrected gridded data set for precipitation, which is this one right here. Open. Then I'll select all the records, click Next. Now select that shapefile again. That's in the GIS directory right here. Okay, and then click Next. Now let's just put it directly into that data directory, that data.dss file right here. We don't need to create a separate time series, but we could. But we know it's just going to be those two records, one for incremental and then one for cumulative. So for part F, I need to be careful here and make sure that I type in a unique path. So for part F, I'll do mrms normalized and then click Next. All right, that's done. So close. Okay. And let's go back to that data directory, view, refresh. Now we have two records here for MRMS normalized. Let's go ahead and highlight the 3 precipitation cumulative records and then click the graph button. All right, looks good. Let me change the colors here. I'm going to go up to Edit, Plot Properties. This just makes it easier to see if I make the lines a little thicker, and then also make the colors a little bit more distinct, like red, for instance. And then instead of gray, we could maybe go with dark green. Is that a line? Yep. And then, okay, apply and okay. All right, great. So the blue line here was the uncorrected MRMS precipitation data. And then the red line is the corrected or normalized MRMS data. And you can see that it's much closer to the PRISM total cumulative data. Let me go ahead and look at the actual numbers. If I scroll down to the very bottom, it was 4.01 cumulative inches of rainfall over that April month, but now it's up to 7.2225, and that was based on the normal of 7.2970. So it's a little bit different. Again, that's partially because of the normalization period that I selected, but of course, much better than down here at 4.01. So that concludes our exercise here. Again, if you were going to use a gridded precipitation data, you could now use the normalized MRMS data, which is not only assumed to be accurate on a temporal basis, but also a total volume by normalizing that gridded data set based on the daily PRISM totals that are assumed to be correct.